everybody. Good morning or afternoon or evening. I don't know where you are. Here it's early afternoon. Welcome to our Machinations webinar. I am Nicolas. I am a game designer and diagrams architect in Machinations. And here with me I have also Harry Ashton, who's also an economy designer and diagrams architect in Machinations. And today we're going to look at how to balance and design loot boxes in Machinations. Specifically, we are going to start by looking at how loot boxes work overall and how to build them in Machinations. Then we are going to look at an example of card packs. Specifically, we are going to take an example of Hearthstone and how you can also manage duplicate items, in this case it's cards, in Hearthstone, because sometimes you can get duplicate cards when you open a card pack, so there's a way to manage that. Then we'll have an overview of how to integrate our diagram, our Machinations diagram, with Spreadsheet. Then we are going to look at how to balance our system, our loot box system, specifically in the terms of what progression or monetization goals we have. And by the end of the session, we'll have a round of questions. So please, we'll have a round at the end, but of course you can ask any questions that you want in the chat and we'll be glad to answer all of them. And speaking of chat, I'm going to ask you, well, I've seen that some of you are already interacting in the chat, but I'm going to ask you if you can introduce yourselves. Just remember to send the message to everyone so we can all see, specifically like who you are, where you are, what country you are, what studio you're from, if you're from any studio or in indie, and why you're interested specifically in this webinar. And before we start, before I give the floor to Harry, I'm going to have an overview of what type of system we want to implement. This is a very generic loot box system, but overall, players will win a loot box on a certain event. Let's say they win a game, they purchase something in a shop, they purchase a loot box, so they will get one. Once they open a loot box, they will collect items. In our case, will be cards, but can be any type of item. Sometimes those items can be duplicates, so players can scrap them to get any resource, which can be a material, and then they can salvage that material to craft more items. So they will repeat this entire loop, this entire process, until they get their entire collection. So the purpose of the players is to get all of the items from that collection. So the question that we want to answer in this session is how many boxes do players need to open to collect all of the items? That is, you can also turn this into how long it will take them to get all of the items. So to answer this question, I will leave the floor to Harry Ashton.
So obviously we're going to use Machinations to answer the question that Nick mentioned, but it's worth asking why we're using Machinations other than some other tool like a spreadsheet or a Python script. And there's a few reasons for that. One of them is just Machinations is a tool that's specifically built for running simulations and running multiple simulations, specifically Monte Carlo simulations. We'll get into what those are in a bit. But the other important thing is that this is sort of a separate environment to run tests on, so you don't need to sort of clutter your spreadsheets with lots of cluttered formulas and that kind of thing. But also, the other important thing about this process is that with this inbuilt Monte Carlo simulation that we've got in Machinations, every time we run these diagrams, we're going to get slightly different results based on the randomness of the system. So this simple setup, which we're going to expand on over time, is basically simulating the fundamentals of a loot box, which is the opening of a loot box, the collection of a certain number of items inside that loot box. In this case, we've got 5 of them. And then we're going to determine randomly what the rarity of those items is. And you can see based on these percentages that we've defined, there's going to be a different rate at which we're going to accumulate those different rarities of cards. So you can see here, the commons are most likely. And in fact, the player here in this simulation that we're running right now is getting very unlucky because they still haven't collected a legendary. So you can see they've opened 27 card packs or loot boxes. They still haven't got a legendary. If I run this again, maybe they'll get very lucky and get one immediately. Another time, maybe they'll get the average. And it's important to understand the spread of the results that you're getting, which Machinations can do by default without needing any extra special formulas or anything. The value of that is not just to understand the potential spread of outcomes that players can encounter in your game, but it's also a good test case against the extremes. So you could get a player that's getting extremely unlucky, and in especially collectible card games, which are the sort of precursor loot box system. If people don't get a legendary within a few card packs, if they go a long time without collecting any, they're going to start thinking the system's rigged against them when really it's just they got unlucky. And if you've got a small community of players, that one player who's very unlucky could go and review bomb your game, and now you've basically your UA campaign is ruined because people go to the App Store, they see this one review saying the loot box system's no good. But the opposite can happen as well. What if you collect way too many legendaries too quickly? What if you have a release schedule where you're going to release a new collectible system every 6 months, but players are blitzing through the content in about 1 month? You're going to have to either change the content or shorten your release schedule. Otherwise, players are going to run out of things to aim for, and then they might churn from the game. So those are the kinds of considerations you can make with this, with these systems, built-in machinations. This fundamental system here is very basic, and you might wonder from just this system here why loot boxes are so enticing, how long they last, but also how dangerous they can be for enabling addictive behavior in players, and all these other considerations. This simple model that we've got here doesn't take into account one of the important mechanics of a loot box, which is the ability to collect cards that you've already collected before. The best example that most people will know is that if you went to a McDonald's drive-through and you got a Happy Meal as a child, or as an adult, I guess. But if there's 10 different toys that you could collect in that Happy Meal, the more of those that you collect, the less likely you are every time you go back to get a new one that you haven't collected before. And that can be very frustrating, especially if there's no way to then exchange those copies of the same thing to recollect them. So just as the next stage, we're going to show a system in Machinations which is the same thing but slightly more advanced, using Hearthstone as an example. But the thing that's different here is that each time the player is collecting each of these cards, they've got a chance to either collect a new one or one that they've already owned before, they've already collected before. And you can see based on the percentage of all the cards of that rarity that they've collected, the chance that they're going to collect a new one is decreasing. So as the player's reaching 70% commons collected, the percentage chance that they're going to get a new common is going down, and the percentage chance of getting a duplicate is going up. And that's defined by these percentages here. When you use the other tool in Machinations, which is the charts, you can start to see with each of these rarities how that's being affected over time. And you can start to get a sense from if you take a look at the gray and blue lines, which are the common and rare card collections, it's the percentage that the players already collected. You can see they're starting to curve off. And that's the inherent feedback loop system that you have when you have the ability to collect cards you've already collected. What we can do, which is the other side of Machinations, is to run some predictions, which are basically what I'm doing here, but without the visual animations, so we can just get instant results. But also we're going to run this multiple times using the Monte Carlo method, which is effectively just running the same system over and over and seeing what the different outcomes are. And this could represent different players going through the same system. Just for speediness, we've only done 10 predictions here. Usually you want at least 30 and probably a lot more than that. But from these first 10 predictions that we've run, each of these lines is showing a different trajectory for a different player. So you can see, if you pay attention specifically to the yellow line, which is looking at the percentage of legendaries collected, so the rarest type of card, you can see there's a big spread in the percentage that a player is collecting. These sort of lower lines here are players that are relatively unlucky, so they're not collecting very many at all, and it's taking them a lot of time to start to collect ones potentially that they want to own. Whereas the players at the top here are collecting a lot more. And just as a side note, the reason that this kind of information is important is because it's starting to get into what's the player's experience of the game. Like, are they feeling like they're being cheated? Because randomness can cheat a player even if it's completely unbiased. So we need to take into account the spread of those results, but we can, if we wanted to, also take a look at what the mean average of a player is if we want sort of very low level conclusions. So this is what we're starting to get here. We're going to move on to a bit more, but we're just a natural stopping point to pause for any questions or any things I've forgotten.
Yes, please let us know if you have any questions. I think I haven't seen so far, but I was going to add, just as a side note, for those people who may not have done anything in Machinations. First of all, when you start, like Harry, when he did the analysis of Hearthstone, one of the things that he had to define is what a step is. And for him, one step, it's like what I said in the beginning, it's you need to know at what point they get a loot box. So maybe in our case, a step is I open a card pack or a loot box in this case. So every step of the simulation, the player opens a card pack. That source, the triangle that you see there, it's the actual action, open card pack. We don't know actually how they got that pack, but they just open it and they get 5 cards. So the next symbol that you see there, it's a gate, and the gate with the dice, it means that it's a random gate. So everything that you send through that gate will distribute in a random way, depending on the probabilities that Harry said on the connections that are the output of the gate. For example, any card has a 72% of being common, if I'm not wrong. Yeah. So that depends on how your system is. Maybe you want to play with those probabilities, of course. And also when he showed the chart, everything in the x-axis, thanks Harry, everything in the x-axis means a moment when they open a card pack. And what you see in the y-axis, it's the percentage of completion of each rarity. So remember that there are two things that we always have to set. First of all, what a step is, and also what we want to achieve. So one of the other things that Harry has there is card packs opened. So our goal is to know how many they will open and how long it will take for them to get to the 100%.
Yeah.
So
yeah, so because this particular model we haven't modeled anything about where those card packs come from. The reason we've done that is because we want to segment out the systems. There's not really any particular reason why you'd need to put information about where those card packs are coming from inside of this model. What you can do is run a separate model to figure out how long players are collecting card packs, or you can insert your own assumptions into this model. For a game like Hearthstone, because they've got so much player data, they can actually figure out things like how often players are actually collecting cards, and they can make an inference from that of how much time this represents. In this case, you might not be able to see it, but this number here is telling us that it's about 1,300 days of play in order to, the player hasn't actually completed all of the collection yet, even after 1,000 card packs, and we're going to see why in a minute, but this is with an assumption about how long it takes to collect cards. You can then make an inference about how long that takes. If you know what the price of a card pack is in the store, or how much it costs in gold, you can also make inferences about the amount of spend depth you've got in your economy as well. But the reason this is looking quite slow at the moment is because we haven't introduced that that system where you're being compensated for the cards which you already own. So that's what's going to be the next step here, is to introduce, if you were designing this system, you would introduce a system like what loot boxes do at the moment, which is basically destroying the duplicates and creating a currency which you can then reinvest. Most of the time it's to reinvest into creating cards you actually want, but it could be something else. In the design process, that's the kind of thing you could do. Actually, just to start off with, so I want to show this in Hearthstone. It's called disenchanting. So you take the cards that you've collected already and you destroy them and you get arcane dust out. So at the start of the simulation here, the player's not going to be collecting much duplicates, so there's no dust being collected. If I just, oh, actually there was a little bit there. So you can see if the player collects a duplicate, it immediately gets disenchanted and turned into arcane dust. The next stage of that is to then use that currency to reinvest, to actually craft cards that you want. So, and the equivalent in other loot box systems like Overwatch or Apex Legends is to reinvest into items that you actually want. So it's not just a card game thing. This is pretty common. So as you start to collect this arcane dust, you'll eventually use that to craft a card that you don't already own. Again, in Hearthstone's case, it takes a long time for you to be able to start crafting things. What you'll also notice as a side note in this model is that we've got this red construction here, which is sort of Machination standard, a best practice, a best practice system, which is just showing a decision tree for the player. So here the player has a decision of what type of card to craft, and you'd expect that they'd be much more likely to craft an epic or a legendary, and very unlikely to craft a common or a rare. So what we've got in this decision tree here is just the relative chance that they're going to craft of a certain rarity, and you can see the odds of them crafting an epic or a legendary is much higher. So over time, if we wait long enough, we will see this amount be depleted and then consumed to be reinvested into cards that you don't own yet. So again, the same process applies here. If we run these simulations and then compare the results, we can start to get a sense of what effect that's had. So if I just quickly rename these so we can see the difference. So this is going to be, so now what we've got here, I've just set up this this chart so that we can see both what we had before and what we have now. So this is like A/B testing. On the bottom, we've got the control, which was what we saw earlier, and the disenchanting, which is the new system. So that's with the player's ability to craft cards that they don't own yet. And you can see immediately that the player is able to complete the collection a lot faster. You can see as that legendary line hits the 100% mark, that means that they've completed the collection. And you can see, as opposed to before, they can actually complete the entire collection within the number of card packs we've limited this simulation to. So it was 1,000 card packs at maximum. But here it's looking like the player is able to complete that collection somewhere between 700 and 800 card packs. But if we zoom in a little bit on this chart here, you can see there's still quite a big spread. Like a spread of 100 is still pretty big. So, and you can see, must have accidentally shifted it. You can see there's still a big variation there, and there's still a lot of unpredictability and potential for players to get frustrated or potentially get very far ahead and then run out of content. That's another good stopping point if there are any questions or if you wanted to mention anything, Nick.
I was going to add something in the diagram that you've shown. I think something that's very important. And so, for example, the gate that Harry added to the right, choose rarity to craft next, that's a very good way of adding player behavior or player agency. So Vlad is asking, for example, how did you choose the weights in this case? Yeah. I think you're talking, Vlad, I think you're talking about the weights, these specific weights.
Yeah. So it's a combination of assumptions that you need to make in order to build a model, but it's also a bit of sort of mathematical intuition. So what it's doing is you have to think about how many commons how many cards of each rarity the player still hasn't collected. Because if you think about it, if there's one card, like one legendary that the player really wants, if they've already collected 99 out of 100 legendaries, the odds that that last legendary that they haven't collected yet is the one that they really want is quite low. Odds are they've already got it before. So the more of that rarity that you've already collected, the less likely you are to want one of the ones that's remaining. But also there's an inherent preference there, which you have to sort of make an assumption about, or you can rely on existing player data if you have that. So sort of fundamentally, when you start running this model, before you've even collected any cards at all, you can see there's some base values here. I've assumed that a legendary, you're 4 times more likely to want to craft a legendary than you are to craft an epic, and same sort of relation between the other cards. And that's just based on how enticing you think the cards are, because legendaries are either more powerful, more attractive, or just generally more enticing. Even if they don't have a gameplay advantage, you probably expect that players will want those legendaries more than the other cards. So that's where you get those assumptions. But again, you can use player data as well if you have that.
Yes, absolutely. And I was going to add that you can also change that behavior. Maybe this is a more efficient way, I think, but maybe you want to model a player that's not very efficient, and they say, okay, I will craft commons because I want. So you can play with these weights, and this is a good way of adding behavior. It's just using these gates with state connection, and specifically random gates, because there is where you can like add this behavior. Amir is asking if these weights are just simple probability numbers like percentages.
Yeah, they're slightly different. So you can see here with these gates over here, they're actual percentages, whereas these are numbers, but they're ratios rather than percentages, but they end up working the same way. It's just up to you which you prefer. In this case, the weights are a bit easier to work with.
Sorry, one side note, it's you cannot mix percentages and weights and not percentages because it won't work. It has to be either or. It has to be either percentages or weights like Harry added here.
Yeah, and just as a peek behind the scenes, there is stuff like we like to use layers because if you're presenting this to somebody in your team, you don't really need to show them all the background details. This is kind of like collapsing a code block. So there is some calculations going on here, but even so, you can see it's not really that complicated. It's best to keep things as simple as possible, unless you really know exactly how players behave. Because if you funnel in on how you think players behave, you're excluding all the other possibilities that they might take, which then you might just get bad data. It's better to have roughly random data as opposed to very specific data that might not catch actual player behavior in it. Yeah, let's hide that again. Are there any other questions?
No, I think for now we can move on.
Yeah, because that kind of was quite a good transition into the next step, which is to the balancing workflow. So we've got the diagram now, but now we've got a scenario where if we took a look at these results and we thought it was still taking the player too long to complete their collection, we could then go back and modify some of these values in order to see if we can make it take players less time or less dollars or less gold or whatever KPI you want. The way this model's designed at the moment, in order to change those values, you could come directly into the diagram and change those values. So I could change these percentages and retype new ones. But what's generally better in terms of workflow, especially on live games, is to integrate this with spreadsheets, which I've yet to see a game design studio that doesn't have some form of spreadsheet where their data is stored, so you can leverage those to get the best out of Machination. And so what we're going to do now, I'm going to load a different version of the diagram which has everything already integrated with the spreadsheet. So if I take a look at this now, so you'll notice there's some variable names here instead of numbers. So what that's actually doing here is it's grabbing data from this spreadsheet and pulling it directly in. So if we wanted to make a balance change, we could go here, make a change, and that will automatically be updated in the spreadsheet. So this is where it'd be quite interesting to see what the audience thinks about what balance change you think it would be best to make if you wanted to reduce the time it took to complete the full collection. So if anybody's got any ideas, feel free to suggest those. There's multiple correct answers. They're all correct, but there's some that are gonna be slightly more interesting. So hopefully somebody finds the right answer.
So I don't know if anyone has an idea of what we should change to make this faster. That is, so we need less card packs to complete the entire collection. Benji said, and have the probabilities run as variables and adjust it too far from the mean.
What was that?
Benji said, have the probabilities run as variables and adjust it too far from the mean.
Oh, is that like a self-correcting system? Maybe. For the demo, we're just going to stick with like directly changing numbers rather than structural changes. But that would, if I've got that right, that would be one way. Just to quickly clarify what these variables mean. So this is the choice. I mean, there's some others over here, but we'll just focus on this sheet. So for each of the rarities, you've got the drop chances, which is the relative odds of collecting a card of each rarity. Card count, which if you're designing a card game or probably any loot box system that's got a lot of cosmetics, you probably don't want to tweak these too much. At least you don't want to increase the amount, because that means you're going to have to ask the art team for more assets. So you could change the relative proportions of them, but not the total amount. Disenchant value and craft cost, those are the how much of the dust you get from destroying duplicate cards and how much it costs to create new ones. Craft preference, which is actually that was the segue that I was making earlier, is that's where these values are coming from. So when I run this diagram, you can see those values, which are the same as the ones here multiplied up. But so if anybody has a preference for which one to change here, then I'll go with that one.
And someone is saying decrease common and increase legendary to ensure users are getting closer to completing a pack, or increase arcane dust.
Is that the
increase
rarity?
Craft costs?
Oh, the craft costs. Okay, yeah. So does that mean level them out or just decrease them all?
Katerina said decrease craft costs.
Okay, yeah, I'll just decrease them then. I'll do divided by 4 just so I don't have to do lots of mental maths.
Someone said increase. Sorry, someone said increase drop chances or increase disenchant value. But yeah, sometimes someone also pointed out, which can be true, that it can be illegal if you change the drop chances.
Yeah, yeah.
So maybe we should stick to legal things.
Yeah. I'm toying between using an extreme case just to show the difference or doing something that's actually reasonable. I'll just halve these rather than divide them by 4. So if
people are agreeing with decreasing craft cost.
Yeah, okay. So if I go back to the diagram, so I've got some variables configured here. So we've got the data coming in from the spreadsheet, which is here. So if I hit refresh, I didn't actually see what it was before, but I'm hoping it's updated correctly now. You probably saw that change. It doesn't matter anyway, because it's gonna work when I run this. So if I rerun now, and I'm gonna rename this, so and then compare that with, actually we want disenchanting to compare to. We can compare again here, and you can see it's had the positive effect that we wanted. It's reduced the time it takes to complete the collection. Again, it's a bit hard to see on the screen probably, but you can compare the two scenarios here to figure out how much of the collection is actually being completed at any one point. If we go to the total number of card packs open that are required to completely 100% the collection, you can see on average in the original case, which is the top chart, it was about 700 card packs you need to complete the collection, whereas 500 for the new system. So we've had a positive impact there, which is good. Probably what you'd want to do in this case, especially if you're sort of have your business model set up, is you'd want to know it. You'd want to have a very particular number in mind for these things. For instance, like the equivalent dollar spend. So that's telling you how much the upper spend depth is on your economy, or the amount of gold if you spent with soft currency there is, or just how much time it takes in comparison. So in this case, how many days it takes to complete all the content. If you have those things in mind, you can figure out whether you've actually made a positive change or not, because we might have just overshot the goal here. Maybe it was sort of like we sort of wanted somewhere in the middle of these two. So it was so we're not going to get into this today, but to just introduce the idea, because this will probably be the subject of another webinar. But we've introduced a feature which you can use to basically define the goal that you want and then modify the variables so that you get the intended result. So it's kind of the other direction to what we did here. Here we changed the values and then we got the results. What if you wanted to know what variables you needed to get a particular result? So that's what the balancer does, and that will probably be a separate session. But we've got a lot of documentation on that to look into if you're interested. That's the sort of the overarching idea here. The thing that's worth reiterating on is just how important this is in terms of getting this tested before a game is launched or a new season of content for a loot box is released. And it's also important for ethical reasons as well. You don't want to effectively force the player to have to spend on the game in order to get ahead. And especially with card games, you've got a general problem where if you're releasing content too quickly, then the players who actually can afford to complete the collection with their own money will get ahead. And the players who can't keep up will start to get out-competed. So there's all these kinds of considerations that you need to make, both business and ethical. There's other things that you can do. We're not going to show this in this session, I don't think, but there are things you can do rather than just simply changing numbers. You can introduce new mechanics. Something that Hearthstone's done is partially removed the ability to collect copies of cards, which means that the system feels inherently fairer, but it actually doesn't have a huge effect on the time it takes to complete the collection, which is a good move for ethical reasons. And also it's less frustrating for players when they feel like the system's rigged against them. So that's, I think, a good point to stop for any questions we've missed, or if I've missed anything I can go over here.
Yeah, I was going to add something Cesar said before, that if if you want the strategy, if you want the absolute fastest method to unlock all cards, I think the best method is to look at total dust needed to craft remaining cards. So you counted all of the dust that you get from dupes, and yeah, it's like a way for a player to get that to like strategy. Someone at the end, they asked, does a sheet connection work with formula in cells as well, or does it need pure values?
Yeah, you can't pass a formula in here. Like if I did, it won't do 1 + 1. But that's more a limitation of the spreadsheet, because you can't read text when you export a spreadsheet. So
yeah, so if let's say you have a formula, so right now that has a formula behind that, but the result has to be a value, an actual number. Because, for example, if I'm not wrong, if you have a date, that won't be understood, or if you have a string. So you can add a formula behind, but the final result of the cell has to be a number. It cannot also be a currency, because I tested that, so it has to be an actual number.
You can have actual formulas in here, though. So if I just, you can configure the formulas directly into Machinations. So this is just a simple percentage calculation, but you can see that's it's grabbing a variable, but it's also manipulating stuff on the diagram itself.
Absolutely. So whenever you want to, let's say you have a formula, a complex formula like an exponential formula or logarithmic or something like this, you can't read that from a spreadsheet. If you want that formula to calculate depending on values of some components, you need to add that to a register. So there are two main components here for all of those who don't know. So you have pools. So pools are used to, like, for example, there Harry zooming in new epics. So pools are used to store something. But what you have below, just right there, is a register. So a pool is just like a cell that you add or remove things, resources in this case, and a register is calculated with the values that you have in new epics. So for example, here, the percentage of epics that they were collected depends on new epics pool. So whenever you want to add formulas, you add them in a register, and whenever you want to count, decrease or increase something, you are going to use a pool, which is going to be used to store. And also with the integration with spreadsheets, it's just what Harry showed there. It's called a custom variable. So in this case, it might be too simple, but maybe sometimes you have a lot of player data, which might happen. You might have a lot of data or a huge table. Let's say you have the probability of getting a card for every card that you have, and maybe you want to model the system. Then you can read the entire spreadsheet and you can access specific elements. So here, everything that Harry has there on the left, it's a custom variable. So the integration is quite simple. You just use a query to get the values from the spreadsheet, and then what Harry did there on the resource connection, for example, before this gate, he's using the name of the custom variable with the position. So it's quite simple. There's a lot of this in the documentation also. And what Cesar said also, careful with value format in spreadsheets. Do not read number format, it should be automatic. And Andres Piso asked, how can I configure the model to guarantee, for example, at least one random legendary item for every 50 packs opened?
So if it's, well, there's two different, there's the version where it's, if you haven't collected one within 50 packs, then it will give you one. Or if it's every 50, it will give you exactly one. You can do both of those things. They're slightly different, but that would involve something called a deterministic gate, which this isn't going to work, but just to show what it does is this is giving you exact fractions. So where before it was a 72% chance to get a common, now it's saying exactly 72% of the cards coming in should go to commons, and then however much percentage for each of them. But you could use a deterministic gate to effectively say that one of those cards in the pack must go to the legendary. So that's the process that you'd use there. So it's mixing in a bit of randomness and a bit of determinism to get the outcome that you want.
Yeah, and also I don't want to get into the nitty-gritty of the solution, but maybe you can create a pool, because he said, for example, every 50 packs opened. So maybe this pool it's counting how many packs you've already opened, and if you get to 50 and you haven't got any legendary items, then you will add something that says, okay, now, like Harry said, now do something deterministically and now get a legendary item. Whenever you want to do something like this, like every 50 or every certain number, and you want to count, you need to use a pool for that. So you will do something like, okay, I will count. If you get a legendary, then it's fine. You already met the requirement. You should also maybe use a pool that has like a Boolean state and says a legendary already given or already obtained, and it will drain or will become 0 once you already gave a legendary item. So awesome. So I think we don't have any more questions. And someone asked before about this diagram. Yes, we're going to share it afterwards. in our community. I think it's on Discord, if I'm not wrong. And
yeah, we can post it in the chat as well.
Yeah,
I've got a not this exact version, but just a copy of it that we'll send in a second.
awesome. And we'll also upload the recording of this webinar. So for all of those that joined later or want to look at it afterwards. Great. And Alex said that he will also mail the participants with the recording and models. So thank you everyone for being here and for the participation. Please, if you have any more questions, you can reach out to us on Discord, and we're glad to help you. And I hope this has been helpful. And yes, now Alex posted all of it: Discord, YouTube, LinkedIn. So
I've added the model to the chart as well.
Awesome.
If you can find it in the thread.
Awesome. But if any of you lost it, in any case, we are going to send it afterwards. So thanks everyone. I hope you have a nice day. Thank you, Harry, of course, for your great job. And we'll see each other on our next webinar. Thank you, everyone.